Hey everybody, this is Larry. What am I doing? Uh this is day 9 of the Leetcode April Day Challenge. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about today's poem. We have a contest in 2.5 hours. I'm excited for that. We'll see how that goes. Though it is kind of later in my bedtime, but maybe once a week is fine. Today's poem is also. I hope everyone's having a great weekend. By the way, happy you know, uh, Easter. Where is that today? I don't know. I don't know when you're watching it, right? So, whatever you're celebrating, happy weekend, all right? 1857, largest color value in a directed graph. Yeah, so make sure you hit the like button, hit the subscribe button, join me on Discord, I suppose. Okay, so there's a directed graph. There are n colored nodes and m edges. Okay, the nodes are numbered from 0 to n minus 1. Okay. Given a string colors where colors of I is a lowercase English letter representing the color of the ith node, 0 index. You're also given a 2D array edges. Okay, so the edges, the directed edges. A routed path in the graph is a sequence of nodes. Okay, it's a path, defining a path. The color value of the path is the number of nodes that are colored the most frequently occurring color along that path. The color value. Return the largest color value of any routed path in a given graph, or -1 if the graph contains a cycle. Okay. So basically, here do you always want to start at anything? So looking at quickly at the constraints, v and y are 10 to the 5th, so we want something linear, or at least n log n at the worst case, probably. My first thought is DFS with memorization, but I don't know that that is good. How many colors are there? Maybe that could be a thing. Is that? Colors can be of lowercase English letters. That's interesting, right? Because it's interesting because that means that there are most 26 colors. And then now the question is, can you just do it for every color, right? Because then now you have a DAG, okay. So you have to there are a few components. There's you have to find a cycle. If there's a cycle, it's going to be a -1. That's pretty standard stuff. And then let's say there are no cycles, then by definition it's a DAG because there's no cycles. And then with a DAG you can do dynamic programming for each of the colors, and then you have 26, and dynamic programming in this case is just going to be linear, or v plus y, which should be fine, and then times 26, which is a little bit slow maybe, but should be okay. So yeah, let's do that. I think that should be fast enough. Yeah, right. So now first we have to do the cycle thing. How do you determine if there's a cycle? If there's a back edge going to something that's not the parent, right? So we're gonna do that pretty quickly, yeah. I'm gonna do it with depth first search, or recursion. Maybe I could do it with breadth first search or a queue, but I think it doesn't really matter that much either way. So let's see. N is your length of colors. Almost type the other colors, but yeah, E is adjacency list is equal edges, and this is whatchamacallit, right? This is what do you call it? This is a DAG is what I mean. So, or it's a directed edge. So you only have one. It's going from A to B, right? Okay. Just want to make sure that I get the direction correct. Okay. So then now determine whether there's a cycle, right? And then yeah, I mean, I think that should be pretty straight. It should be pretty straightforward, but I don't. It's been a while. I have to remember how to write it, or like with the edge cases, right? I'm tempted to just like have a used, and this is what speaks to what sometimes when you out practice on certain things, it does take a little bit of time to just like go for the edge cases and then reproof stuff, right? Where you have our practice, and this is the difference between a lot of rating points if you care about competitive and contest, is that I'm just thinking about edge cases and forgetting how to handle them, and then try to prove to myself how to handle them, right? Oh, excuse me. Huh. How do you do? Maybe I'll just do a breadth search then. No, but then you get a key. Because the thing that I'm just trying to think is whether I can just go like find a but there could be multiple routes, right? Which is, wait, is it connected? This graph doesn't have to be connected, right? So unless I miss, yeah, huh? So then if we start at the wrong node, given like a cycle and a leaf or something, or a couple of leaves, then we have to figure out how to do it without like doing n square by accident, right? So that's kind of where I'm at. Wow, I really should be better about this though. So maybe this is good practice, because I think this is pretty fundamental, and I probably should be a little bit better about this. But it's basically you could find a thing that has an in degree of 0, and then what? And then you do some recursive thing, sure. But then what? How do you do it for the next one? I guess you could just do like the 3-color thing. I was hoping that I didn't have to. That's why I was trying to think about the symbol thing, but it's been a while. Maybe I'm reinventing the wheels. Maybe not. It's always sometimes a little bit hard to figure out which way to go. But okay, fine. Okay, I remember now. Oh, oops. Oh, yeah. This thing colors is also a little bit wonky. That's why. Say what? I always forget whether you go from white to gray or gray to white, but oh well, doesn't really matter. Just as long as they're distinct. And then basically, yeah. Can I spell colors? I guess we'll just set this as well. If return -1, right? Something like that. And then now, we set it to gray, and then after the finished processes, we set it to black, right? if this is something that we're currently visiting, then we return true. Right. I mean, and in theory, there's stuff to clean up, but I guess it always just returns -1 anyway, so I think we're good here. Although, if it's gray, then it, if visited colors, if index is to go to white, then we should visit it. Oh, not index. This is v. Whoops, this would have been way awkward. Return true. I think that's it. Return false, I suppose, and the other ones. Okay. Let's see if that works for that case. Yep. Let me actually make something slightly more complicated than that. Just to kind of test this. Doesn't really matter. Okay, so it's still good, but still not 100% convinced. It's been a while, but okay. So then now this is no cycles in this graph, and then we can just do you know, for we in set of colors, right? Or maybe C, right? Then we go let's say best is equal to 0. How do we want to set it up? Best is equal to max. Best calculate. So calculate C, return best, and this is just a way just to hide a loop. I think really. So now we have color, and then yeah, and then we have. No, I think we can just straight out cache. I'm going to use memorization here, but yeah, I mean, okay, fine. I was going to just like be lazy and use memorize or memo, but I could do it without that. But yeah, so basically we go dp is equal to none times n has cache, and finally just write cache. Right. I'm not going to explain this part too much in this video because I think I do DP in a lot of videos, and it may be wrong, so then it will be very awkward if that's the case. So definitely check that out. But the idea here is just knowing ahead of time that, well, I'll do the DP calculation now. Get longest, right? Basically, this function has, you know, index can go from 0 to n, so this is going to be O of n number of inputs, and ideally in total this is going to be v plus y because we just look at all the edges once. Is the basically the idea, even though, you know, amortized or total, whatever, yeah, right. So then now we just return calc. So then best is equal to 0 for I in range of n, and I have to add the color here actually. That's okay for shadowing. Best is equal to max best of get longest starting from I, right? And of course this assumes that we have no cycle already, which we in theory proved that we do not. So yeah, and then, oh yeah, well, we don't have to, I guess this is already specifically color, so I don't think I need it here. It is already in the helper function, because that doesn't change in the scope of this function. So yeah, if has cache of index, return cache of index. This is just normal dynamic programming things, or memorization in this specific case. And then basically if what's it called, colors, index, yeah, just you go to color, then how do I want to write this? 0 maybe. Naming stuff is hard. I'm just gonna name it current for now. And then for v in, what's my graph thing called? Adjacency list of index. I guess I still need a best. All right. So basically now we're just recursively going, okay, get me the longest thing, right, plus current. And that should be good. Well, that should be good, but I forget to cache. Wrong answer though. Oh, I don't know if I remember to count stuff, because best should be at least be current. That's why, because there's no outgoing edge. I was wondering about that best case or the base case. Okay. I guess another way I could write it is set 0 to 0, and then something like that. Maybe is a little bit slightly better. Okay. Let me just give it submit because I'm lazy to think of edge cases. It looks okay. 1184 streak. Oh, it's actually appending very fast. But yeah. What did I do last time? Because I mostly try to do the same thing. Oh, I did the same thing with Psycho. I thought that, okay. It's been a while. Really need to do better on the Psycho stuff. This looks actually very similar to what I have now, except for that I feel maybe I'm a little bit proud of it. Okay, but yeah, going over the code really quickly. This is basically the Psycho determination. Kind of had to, that's what I mean by being out of shape and out of practice, right? But still got to it, so I guess I'm happy about that. This is just to set up the adjacency list, and then here it just takes the it asks the question, what is the best color in the graph, taking advantage of the fact that there are only 26 colors. And then here is just for each color, do the longest path in the DAG, right? And that's a very standard, which is a very standard dynamic programming problem, which is going to be O of V plus E, which sometimes can be slow because of the size of the E. But in this case, V plus E is pretty fine. Yeah. Cool. Let me show you the top again. Let me show you the bottom again. If you'd like to pause and kind of check out what I did. But that's all I have for this one. Yeah, let me know what you think. Stay good, stay healthy, to good mental health. I'll see y'all later. Take care. Bye-bye.